Which of the following differential equations corresponds to the slope field given below? Let's start checking off which ones do not. First off, let's look at, I like to look at zeros first. Whenever x is 0, it appears that the slope is also 0. So let's look here. If x is 0, this is undefined. If x is 0, this is undefined. If x is 0, this one could be 0. If x is 0, this one could be 0. And this one could be 0. All right, so we've knocked off 2. What should we look at next? I might look at a point like 1, 1, let's call that, or maybe 2, 2. It really doesn't matter because when x equals y, the slope appears to be 1. So that would cross off this one because that would give me a -1. That would also cross off this one because 1 times 1 or 2 times 2, like the only time this would be that would be somewhere in that square root of whatever range. So I think we're basically there right away. We got there fast. Yeah, 1 divided by 1, 2 divided by 2, 3 divided by 3. Like, that gets there fast. Let's just double check it, maybe right here. If it was -1, 1, I get a -1. -2, 2, yeah. I think that was, one of the decent differential equation slope field ones that we definitely would like to see on our test. If f is a continuous function and f prime of x equals f of x for all x, then the integral from 1 to 5 of f of 3 of x equals, yeah, let's take a look. What do we get if we were to just integrate this? The integral of f of x would be big F of x, but we've got this extra chain rule inside there. So a very good recognition on this would be understanding first that the big F of 3x. I guess how I would do this is you could either u substitute and get 3 and remember the 1/3, and I think we got that, or you could kind of picture what the chain rule of this would do. It would multiply by 3, therefore we're going to need that 1/3 from 1 to 5. So let's put that 1/3 in front. Then it's going to be f of, if I put the 5 in, big F of 15 minus big F of 3. Is that somewhere up here for us? If I distribute the 1/3 through, yeah, got it right there. You can kind of see, here would have been if we forgot to multiply by 3. Here would have been, right, if we would have multiplied by 3 instead of taking the 1/3. So definitely some good wrong answers in there as well. G is a function given by g of x equals the integral from 0 to x of e to the -t squared. Which of the following must be true? Let's take a look here. What would g of x is greater than 0, g of x is greater than 0, g of x is less than 0, okay. We've got increasing and we're talking about concave down. So we're talking about increasing and concave down in all these options. We should be thinking about derivatives and second derivatives. So I think what they're assessing here is, can you derive that? What is the derivative of the integral of? And that is just going to be, because it's just an x there, we can actually just put the x in. So e to the -x squared. Now, one thing we should recognize about this is that it's always going to be greater than 0. Why is this always going to be greater than 0? Because even if I put in a large number for x in either direction and square it, e to that power, even if it's a negative number, which they'll all be negative numbers, is just going to be a small number. Negative exponents make fractions, not negative numbers. So therefore, that is always greater than 0. Let's derive that for fun. G double prime equals e to the negative x squared times the derivative of negative x squared would be negative 2x. So there's a chain rule. And what do we know about this? We're going from 0 to 3. And if x is just greater than 0, because it can't be 0, this is always going to be a negative number. This is always going to be a positive number. A positive times a negative is always a negative. So what does that tell us? If the derivative is always greater than 0, it means it's increasing. If the second derivative is always less than 0, that means it's concave down. So let's take a look which ones have increasing and concave down. Increasing, concave down, increasing, concave down. So I guess the two choices we have is the function always greater than 0 or always less than 0? If this is always going to be greater than 0, when I integrate from 0 to x, from 0 to 3, it's always going to be a positive area. Therefore, a is the only one that works. Now they could totally trick you by going to the other side. If you integrated from 0 to negative 3 on this, this is still going to be a positive number because you went the other way. It would be a negative area, but that might be getting a little too deep in this problem. All right. For t greater than 0, the velocity of someone walking along the street is given by v of t, and the particle, the person, is at 2 at time 0. I think there was I cut off a what is the position of the person when the acceleration of the person is first 0. So I guess I'd solve the last part first. Like it says acceleration. When is that 0? So what is a of t is the derivative of v of t. So the derivative of cosine is negative sine. Derivative of sine is cosine. When is that first 0? So when is negative cosine t equal to sine t? Well, if I look at my unit circle, they're equal here, but they're equal in the negative here for the first time. So I guess that would be 3 pi over 4. What is the position there? So now we go to our position, which is the antiderivative of velocity. So if I go for 2 plus, why would I do 2 plus? Because the particle is at 2 when time is 0. From 0 to 3 pi over 4 of cosine t minus sine t. And I do believe this is calculator active, so you could just put in v of t into your calculator. But I think that should add up to 2 plus negative 1. So we've actually gone back 2 in that time, or back 1. So therefore my position will be at 1. The line y equals 3 is a horizontal asymptote to the graph of which of the following functions? I am totally going to put this onto a pre-calculus assessment. This is great. This is chapter 8 of pre-calc. If the degrees, let's go through some pre-calculus. If the degrees of the numerator and denominator in this, then there's no limit. If they are the same, then we just divide the coefficients. And if the bottom is bigger than the numerator, it's 0. So we are looking for 3. Which one do they match? And the coefficients divide to 3. Awesome one to get right there.